So we're going to follow up on the previous presentations and take a closer look at rigid bodies. Now, since our last presentation, I've saved my project and I've quit out of Unity, and now I've relaunched Unity. So I'm working during a second session, and you'll see here that now in my project lists, I have a Gravity Lab project. And under the title, it shows me the path to the project that I'm working on. It also shows me the current version of Unity, or the version of Unity that was used to create this project. So make sure that you audit this path to make sure that you're saving things in an appropriate location. So I've relaunched Unity. I'm going to select my Gravity Lab project. Now, when Unity opens, the scene may be empty. And if you have multiple scenes, now mine's populated, but if you're looking at an empty window, opening up a previous project, as long as you've saved your previous scene, it shouldn't be a problem. Just make sure that you load the last level that you saved. In my case, if I go into my assets folder and I go to LVL01, I'll just double click on that level, and then it loads and populates my scene tab with the content from level 1. So I want to take a closer look at rigid bodies and some other aspects of this basic geometry that we have created. So in the previous presentation, I created this cube, and this cube is going to be something that I want to react to the sphere falling. Now, if you recall, when I hit the play button, I just have a simple rigid body attached to my sphere, and my sphere bumps into the cube and nothing happens. In fact, my cube's floating off the ground a little bit. This is a static object. It's a static geometry, just a default cube. I did change the material, but what I want to do is I want to make this cube part of the physics simulation, or talk to the physics engine inside Unity. And so what I'm going to do is, with this cube selected, just like I did for the sphere, I'm going to go to Components, Physics, and add a rigid body. So now I have a rigid body component attached to my cube, and now when I hit the play button, or I Command P to toggle the play button, you can see that the object, the cube, falls to the ground, and now the sphere actually bumps in and kind of rattles the cube a little bit. I'll use Command P to reset that the game here. And I'm going to modify this just a little bit. I'm going to continue to tweak this a little bit. My goal is to get this sphere to knock over this cube. So I'm going to modify a couple of the properties of this cube object to see if I can get it to react a little different from the sphere. In fact, I might modify the sphere a bit as well. So I'm going to make sure that my cube is selected, and I'm going to take a look at the property inspector. Now, there's a couple things that I want us to take a closer look at. The first thing is that we have a box collider component. Now, this usually comes default with most basic game objects, 3D objects that are created inside Unity. So the cube, sphere, capsule, cylinder, plane, and quad by default should have some sort of collider on it. Now, the collider is represented by this green highlight, these green edges that follow around the box. Now, we can modify this separate from the geometry. There's no need to do this right now, but just for the sake of the demonstration, I could change the size of the collider. And now the collider is wider than the actual object itself. So right now, the sphere is going to bump into something. It's going to stop actually before it hits the polygon of the object, because it's bumping into that collider. So just be mindful that this box collider component is the thing that governs the collision interaction between objects. Now, it doesn't have to have a rigid body to have a collider on it. In fact, if I create another 3D cube, and I'll just move this cube over a little bit and move it down and get it in the way of my original cube, you can see that by default it comes with a box collider as well. And the box collider is going to scale to accommodate the default size of this cube. So if I were to raise the cube up a bit along the y-axis, the scale, the 1-to-1 scale in all x, y, z, will accommodate the overall size of that object. And so if I hit the play button, you can see that we'll bump into this cube. The difference between the two is the white cube does not have a rigid body component assigned to it, and the gray cube does. So we can't move this cube based on physics interactions, okay? So I'm going to select my test cube and get rid of that temporary cube. I'll select my previous cube. I'm going to rename this in a bit to give it a more appropriate name, but I kind of want to get some of the properties dialed in. Now, this box collider, in fact, most components, you'll notice that there's a little checkbox next to the component. So in this case, it says box collider. There's a little checkbox. This indicates whether that component is on or off. So if I uncheck the box collider and I hit the play button or Command P or Control P, you'll see that the box actually falls through the ground because in this case there's no collider. It's not sitting on the surface of this ground plane anymore. I'll make sure I turn that back on. I'm going to create one more cube. And this cube, I'll just kind of move it over and push it down into the same position that it was before. I'll turn its box collider off. Again, this one does not have a rigid body, so it's not being pulled by gravity, but the sphere passes right through it because its box collider is turned off, or its collider is turned off. So the sphere is not interacting with that piece of geometry. Visually it's interacting, but it's not with the physics engine. So I'm going to delete that cube. So we have a couple of things to keep in mind when it comes to our collider, the thing that's actually interacting with the surfaces of our geometry. The other thing is that we have our rigid body component and we have some options that we can manipulate down here. Probably the most important one in this case is the mass of the object. Now this cube is just kind of sitting in space. It falls to the ground. It lands on the surface when we hit play, lands on the ground. And the sphere has a mass and our cube has a mass, and those two are interacting. And right now they're about the same. If I go to my ball, I look at the mass, it has a mass of 1. If I go to my cube, it has a mass of 1 as well. Now, if I make this more or less massive, if I add or reduce the mass of this, it's going to react in different ways. So if I take this mass down to 0.2 and hit the play button, the ball is going to have a different effect on the cube. Now, in this case, it just kind of moves it back and knocks it back just a bit because there's a couple of other factors that are working on it. But I can continue to reduce the mass. We'll talk about angular drag and a few other things, but just for the sake of the demo while I'm here, I'm going to turn off use gravity just to see what happens. I'll hit the play button, and the first thing we see is that the cube doesn't fall to the ground, and when the cube hits it, or excuse me, the sphere hits it, it just kind of floats out into space. Let me change my camera here so we can see a more dramatic view. I'll pull this back just a little bit as well. So gravity is not affecting this object, but we're still having a physics interaction between the two objects. Okay, so just a couple of options to tinker with here. I'll turn gravity back on. Now, the other thing that I want to do while I'm here and focusing on the box collider and the rigid body is I'm simply just going to make, in this case, the x-axis much smaller. So I want this to render or look and act more like a domino, so something that is narrower at its base. In this case, the red axis is represented by the x. So I'll take its scale down, and I'm just kind of eyeballing it, looking at it through the scene here, and then I'll just round off this value to say 0.2. So now when I hit the play button, it falls to the ground, and the sphere will come, and because it doesn't have, it has a very different center of gravity, and its base is very narrow, the sphere will knock it over at this point. So just a couple of things to tinker with and play around with. I'm getting this object kind of dialed in the way that I want it, and later I'll duplicate it and create sort of a domino scene. But I want to stress the importance of kind of getting things dialed in before you start duplicating them, because if you inadvertently make some kind of error and replicate that error across lots of different objects, you're going to have some cleanup to do. So experiment with adding rigid bodies to other objects. Be mindful of the box collider. In the next presentation, we'll talk about adding basic physics materials to objects to get their interactions to react in different ways once again. And then we'll have most of what we need to wrap up this project. We'll talk about make a pass to clean up change some naming conventions and play around with the hierarchy a bit. And then we'll just experiment from there. So we'll catch up in the next presentation.